American Petroleum Institute Specification 6A ISO 10423. Design Performance General Performance Requirements General. Performance requirements specific to you for the product as shipped to condition. All products shall be designed with the perform according with the requirements clause. And this clause in clause 10 while in the pressure of the temperature range with the test fluid consistent with the material of the class of the table 3 for which they are rated. Other requirements include load capability, color cycle, the operating force of the torque. They are 2 performance requirements level of the PR1 and performance requirement 2. The requirement level 2 valves operating and safety valves shall be in performance level. Performance requirement level 2, performance level, and meet the requirements for Annex 1. Surface condition, pressure rating general. Equipment shall be designed to operate with only the following maximum rated working pressure. 2,000, 3,000, 5,000, 10,000, 15,000, 20,000. Thread equipment limitation. Equipment design internal thread end of the outlet connection shall be limited to thread size rated with work pressure table 1 rating design included with the tube and casing hangers. Design consideration design shall take into account with the effect of the containment with the other pressure induced load with the special condition shall also be considered with the pressure rating chain with the crossover with the connector of the pressurizing with a temporary test plug effect with external load bending moments tension etc. on assembly of the components that are not typically expressed in the International Standard CA2. Pressure ratings internal thread end outlet connections over the type of the thread line non-pipe size outside diameter rating work pressure and millipascals and PSI. You have your line pipe, non-pipe threaded, nominal pipe threaded, nominal sizes. Tubing non-upset, external upset, round thread casing, 8 round buttress, extreme line. Temperature rating. General equipment should be designed to operate in one or more specified temperature ratings with a minimum and maximum temperature shown in Table 2. Minimum temperature, the lowest ambient temperature in which the equipment may be subjected. Maximum temperature with the highest temperature in the list of fluid may directly contact the equipment. Design consideration design shall consider the effect of the differential thermal expansion of the temperature for the change of the temperature for the gradient of the equipment that would experience in service of the design of the high temperature rating. X and Y shall take on the consideration effect of the temperature strength level of the Annex G of the guidelines temperature rating consideration. Choose the temperature rating with the ultimate responsibility for the user that making the selection. The user should consider the temperature of the equipment that would experience with the drilling and other production services. And you have temperature rating, temperature classification, Celsius, minimum and maximum degree Fahrenheit, KLPRS, TUV, and room temperature. Hey, Momo. Yeah. Material class rating. General equipment that shall be designed with the materials including metallic for the meat with the requirements set forth in Table 3, but the Table 3 does not define with the present fluenture well-edited environment provides material classes for the increasing level of the severity of the surface condition relative to the corrosivity. Provided with the mechanical property that can be made with the stainless steel may be used in place with the carbon low alloy steel with corrosion resistant alloys may be used in place of stainless steel. Material class. Choosing the material class to ultimate responsibility of the making the selection the user shall consider the various environmental factors reduction variable listed in Annex A. Material requirements show the material class, the minimum material requirements of the body, bonnet, and outlet connections, pressure controlling parts, stem, and the mandrel hangers. Then we have double A, general service, double B, general service, double C, general service, and double D, E, double F, and double H are sour services. Design method, connection, flanges. Flange specified by the internals and national standards as design in accordance with the design criteria methods originally developed by the American Petroleum Institute. Hub and outlet connections. Design end of the outlet connection 16B, 16BX. Use the equipment specified by the international standards shall conform with the material dimensional requirements of ISO 13533. With the clamps meeting with the requirements of ISO 13533 with acceptable installation and the equipment specified in the international standard integral hub meeting requirements of ISO 13533. Casing and hanger, tube hangers, back pressure valve, lock screws, and stems. Case hangers, tube hanger with the back pressure valve, locking stems, as shall be designed to satisfy with the manufacturer documentation, performance characteristics of the condition, as in 4.2 of the manufacturer shall specify with the methods used with the design consistent with acceptable engineering practices. Other end connectors, body and bonds, general other end connectors, bodies and bonds utilize the standard material of the design and the other specified in the international standard should design in accordance with one or more of the following methods. Standard material, those materials or properties meet with exceeding the requirements of Table 5. Other end connectors, body bondings utilize non-standard material designed in accordance with the requirements of 4336. Non-standard materials specified minimum yield strength in excess of 75,000 psi do not meet ductility requirements of Table 5 and standards of 75K materials. In the event of stress calculated in method 4332 for 4336, exceed the allowable stress of the methods identified with the manufacturer, so we use to justify the stress fatigue analysis, localized bearing stress valve beyond the scope of the international standards. ASME method, design method prescribed by the ASME Section 8 of the Division 2, Appendix 4 may be used for the design calculation pressure containing equipment. Designing allowable stress should be limited to the following criteria. Our maximum design stress intensity rating work level is material specified two times the material specified minimum yield strength divided by 3. Maximum allowable general primary membrane stress intensity hydrostatic pressure is equal to 0.83 times the material specified minimum yield strength. Theory of constant energy distortion. Theory of constant energy distortion, also known as von Mises law of the maybe used with the design calculation pressure containing equipment, rule with the consideration discontinuity stress concentration. Beyond the scope of the international standards, however, the basic pressure valve of the vessel block thickness may be sized. Applying triaxial stress based on the hydrostatic test pressure limited to the following criteria. Maximum level equivalent stress, the most highable stress distance for the internal pressure vessels, well computed distortion energy through method, and there is equal to the material specified minimum yield strength. Experimental stress analysis described in the American Society of Mechanical Engineers, VEC Section 8, Division 2, Appendix 6, may be used as an alternate method described in 432 through 433. Design qualification proof test, general as an alternative to the analytical methods above. The pressure rating of the equipment is determined by the hydrostatic evaluated pressure. This vessel part made with equipment for which the maximum allowable working pressure is to be established, not previously have been subject to the pressure greater than 1.5 times the desired anticipated maximum allowable working pressure. Determination of the yield strength method. Yield strength of the material of the part test is determined in accordance with the method prescribed in the applicable material specification. Specimen pressure preparation. Yield strength is determined shall be the average of the 3 or 4 specimens cut out of the part tested after the test is complied. Completed specimens shall be cut with the location stress during the test is not exceeding. The yield strength of the specimen shall not be flame cut, because that might affect the strength of the material. Alternative specimens. Excess stock with the same piece of the material available that have been given the same heat with the treatment added to the pressure part of the test specimen may be cut with excessive stock. Special shall not be removed with the flaming, cutting, other method involving sufficient heat to affect the properties of the specimen. Exemption. Yield strength is not determined by testing specimen. Alternative method given in 43353. Evaluation of the Pro proof test method exterior established maximum allowable working pressure testing procedure instrumentation. Measure strain with the direction maximum stress close of the practical most highly stressed location mean strain gauge of the typical capable of indicating strains of 500 microstrains, and the manufacturer document with the procedures used to determine the location for the strain is used with the measure means with the compensate with the temperature hydrostatic pressure imposed on the gauge application of the pressure gradually increase the hydrostatic pressure on the vessel part until approximately one half of the anticipated working pressure is reached. Thereafter increase the test pressure test approximately 1/10 or less than rated working pressure until the pressure required for the test procedure is reached. Observation after each incremental pressure has been applied with the take of the and record readings of strain gauges and of the hydrostatic pressure relief of the pressure. Determine the permanent strain at each gauge after any of the pressure increment indicating the stress of the strain of the increment over the pressure equal pressure increment. Only one application's increment of the pressure is required. Records. Plot 2 curves of the strain against for the test pressure for the each gauge line with the test progresses. One show of the strain with the under the pressure, one show of the permanent strain with the pressure is removed. The test may be to discontinue with the test pressure for each of the value H will be formally justified desiring the work pressure, but not shall not exceed the pressure. Pull added points for the most highly strained gauge line reaching 2% strain. Floating rating, compute maximum allowable working pressure parts of the tested in subclause 1 of the following equations. Average yield strength determined in accordance with 43352. Pressure is equal to 0.5 times H. The value times system yield, system A. Actual yielded strength of the test specimen. The actual average yielded strength is not determined by the pressure is 0.4 hydrostatic test pressure. Stop in accordance with 43353B. 4336 non-standard material design requirement of design methodology ASME Section 8 Division 2 Appendix 4 shall be used with the design calculation pressure containing equipment that utilizes the non-standard material of the design level of pressure shall be limited with the following criteria. Design intensity rated working pressure, maximum combined primary and secondary stress intensity, maximum allowable general primary stress intensity hydrostatic pressure, Material specified ultimate tensile strength and the material specified yielded strength. Closure bolting, the maximal allowable tensile strength of the closing bolt determine the considering with the initial up and built bolt up and rated working pressure hydrostatic pressure condition with the bolt stress the base time on the root area of the thread with the not exceed the following limit. Maximal allowable tensile strength is equal to 0.8. The material's minimum yield strength. Bolt stressing determine the considering the loading of the closure. They include pressure acting over the seal, area gasket of additional mechanical thermal loads, other parts, all other pressure containing parts, all pressure containing parts. Show the design specify the manufacturer documentation performance characteristics over the condition and 4.2 the manufacturer specify the methods of the be with the design consistent with acceptable engineering practices. 4.3.6 specific equipment requirements are specified in Clause 10. Miscellaneous design information journal in and outlet shall be the integral body of the attached with welding, which means the requirements of Class 6. Product service level 4 equipment and design of the specification level 4 equipment design shall not use fabrication welding tolerances unless otherwise done. Appropriate table figure following the tolerance. Dimension X in the tolerance and plus or minus of 0.5, 0.202 inches. And then XX 200ths of an inch, and then 3,000 of an inch for XXX. Bolt end outlet boring, hole alignment, end and outlet bolt holes, flanges equally spaced and shell straddle, common center line, stud threaded engagement. The thread engagement length of the body studded flanges shall minimum 1 times the outside of the diameter and stud. Other bolting. The stud threaded anchor mean for the design sustained tensile load, equivalent load which can be transferred to stud through fully engaged on test venting, injection gauge level sealing. It's all the test vents, injection gauge connections provided with a leak tight style hydrostatic test pressure over the equipment in which they install the test gauge connection ports 10,000 psi or below. The test gauge connection at 10,000 psi working pressure below shall be the internally threaded conformance method specified in 10.2. Should not be less than 12 millimeters in nominal size. High pressure connections described in 4.4.4.2 may also be used. 15,000, 20,000 psi test gauge connection, 15,000, 20 psi, 20,000 psi working pressure shall be in accordance with 10.11. Vent injection ports shall meet the requirements of manufacturer specification, design, documentation. Documentation design shall include the method, assumption, calculation, design requirements shall include, but not limited to those of the criteria of size, testing, operation, pressure, material, environmental, other pertinent requirements upon which design is to be based. Design, documentation, media shall be clearly legible, reproduce retrievable design documentation will be retained 5 years after the last unit of the model side of the rated working pressure is manufactured. 4.6 design review. The design documentation will be reviewed, verified, and any qualified individual other than an individual who has created original design. Design verification. Manufacturer shall document these design verification procedures. Result of the performance verification. Design and performance verification procedures include acceptance of service safety valves on the water safety valves are given in Annex 1 and additional verification procedure including acceptance criteria given in Annex F to be used if the specified manufacturer or purchaser. 5. Materials, general requirements.